Hi, we're going to be starting a new unit, and that unit is called circles. So our first lesson is 7.1, Intro to Circles, Circles and Circumference. The objective is, how do we determine the parts of a circle and the size of its pieces? So before we delve into circles and its parts, we need to know what is the definition of a circle. A circle is made up of infinite number of points, all equidistant from the center. So equidistant means they're equal from the center. And how do we name a circle? We name it by its center. So we have an example of a circle down below, and the center of the circle is C, so we call it circle C. Or you can draw that little notation that looks like a sun, a little dot on it, or it looks like an I should say, and then put the letter C. So either way represents circle. With the parts of a circle, we have three things that we're going to name. So AF is called the chord. The chord is any segment with endpoints on the circle. So notice that F and A are sitting on the circle. So it's a chord. BE is called the diameter. And the diameter goes right through the circle, the center of the circle. And it is a chord also because both of its endpoints are sitting on the circle. So a chord that passes through the center. And then CD is called the radius. And it's any segment with endpoints that are at the center and on a point on any circle. So CD starts at the center and then it goes to another point that is on the circle. So we have chord, diameter, and radius. And also the plural of radius is radii. And when they say that the circle is made up of infinite number of points and all equidistant from the center, that is basically if you had many radii starting at C and going all around inside the circle, so you can have many of them, that will create that circle. Okay, so let's identify the parts of a circle. We have a circle, we have lines inscribed in it. We're going to learn about what inscribed mean. So they're all inscribed inside the circle. So what is the name of the circle? Let's look for the center. What is the center? It's E. So it's called circle E. Or that notation that looked like an eyeball, E. Name the radii. Remember I said that the plural for radius is radii. So there's more than one radius in that circle. So this where do we find the radius? We start at the center and then go up to another point that's on the circle. So we have EB, EA, ED, and EC. So there's 4 radii in the circle. Name the chords of the circle. Remember that the chord is a segment that has its endpoints sitting on the circle. So let's look for them. We have AB, AD is another one, AC, and BD. So there's 4 of them. Now we need to look for the diameters. It goes right through the center of the circle, and there are 2 of them, BD and AC. And yes, we did label those as chords, but remember a chord is basically 2 endpoints sitting on the circle. And it doesn't matter if it's going through the circle, center of the circle, or below the center, above it, or a little piece of it, doesn't matter. So it's still a chord. But if it goes through the center, it's a diameter. Okay, circumscribe and inscribe. You're going to hear that when you're dealing with circles and another shape that's either outside or inside. So circumscribe means that the circle is drawn around a shape so that the vertices are points on a circle. And inscribe is a circle that is drawn inside a shape so that the circle touches each side once. So if you hear the word circum, so circumvent, circumscribe, well, circumscribe you hear, circumference, so basically means around, like the perimeter. So you got something that's around a certain shape. And inscribe, you hear the word in, inside of something. So that's another way for you to remember and know the difference between circumscribe and inscribe. Circumscribe, it's around a shape. Inscribe is inside a shape. So we have two examples, and they want us to describe the following figures. So the first one, we see a circle, E, and a quadrilateral, ABCD, that is drawn inside. So if we had to describe both of the figures, we would say that quadrilateral ABCD is inscribed in circle E, drawn inside, and circle E is circumscribed around quadrilateral ABCD. Let's do number 2. We have a right triangle. We know it's a right triangle because of the marker, 90-degree marker. And then we have the circle surrounding it. So we can say that a triangle is inscribed in the circle, and we can also say that the circle is circumscribed around the triangle. Again, this is us just using the vocabulary circumscribe and inscribe to know what is going on with the figures. Okay, let's move on to the next. Radius and diameter. What is the relationship between the radius and the diameter of a circle? Well, it's all about the equation, how we set it up, how do we find the diameter, how do we find the radius in the circle. This is stuff that you may have encountered when you're in middle school. The radius is half the diameter, or you can say d over 2. And the diameter is twice the radius. So it takes 2 radii to make a diameter. So we're going to do an example based on radius and diameter. So we have the figure, circle R, and then we have 1, 2, 3, 4, 5, 6 radii in that circle. Remember, radius, the plural is radii, and radius starts at the center of the circle and then goes to another point that's on the circle. So they said if ST is 18, and find RS. So ST is a diameter because it goes through the center of the circle, and we need to find RS. RS starts at the center and then goes to a point on the circle. So that's the radius. So first labeled it, D and R. How do we find R? R is half of the diameter. They gave us a diameter, so we're going to do half of 18, which will give us 9. So the radius is 9. Now let's say that they say that RM is 24. Find QM. RM is the radius, and QM goes through the center of the circle, is the diameter. So we label that. And now we need to find the diameter. How do we find the diameter? It's twice the radius. So it would be 2 times 24 gives you 48 for the diameter. Now let's say if Rn was 2. They said find Rp. Okay, Rn is a radius, and so is Rp. So if Rn is 2, then Rp will also be 2, because the radius is equal. In a circle, the radius are all equal to each other. So both of them are 2. All right, let's go on to the next section. Circumference. What is circumference? Circumference is the distance around a circle. So think of length. So imagine you're running a lap around in the track. You're doing the circumference. Well, if it's a circle-shaped track, then you're doing the circumference. It's the distance around a circle. Or sometimes you think of perimeter. If they ask you, what is the perimeter, circumference, perimeter, it's basically finding the distance around a circle in order to get what they asked you for. So it's a length. So what are the two formulas used to find the circumference of a circle? When it comes in terms of radius, it would be C equals 2 pi r. Again, this is something you may have encountered in middle school. If you forgot, here's the formula. C equals 2 pi r. Circumference equals 2 times pi times the radius. And in terms of diameter, it is C equals pi times d, pi times diameter. So these two are the same, but again, it depends on if they give you the radius or they give you the diameter. Where does this 2r come from? Basically, it's d equals 2r. Remember that diameter is diameter is equal to twice the radius. So if you had diameter, basically you just replace the 2r with d. If you have radius, they gave you radius and looking for the circumference, then you would have 2r. It's the same, you're just replacing the d, but it will be 2r because you have the radius that is given. So again, the same formula is just used differently. It's based on what, in terms of which one, whether radius or diameter. So c equals 2 pi r or c equals pi d. And we know that pi is equal to 3.1415, blah, 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 all that big number, but 3.14 is just fine. And sometimes when it comes to writing the answer for the circumference or whatever it is, we always leave it in terms of pi. We just leave pi as pi. All right, so we're going to do examples based on that. First one says we need to find C, the circumference, if the radius is 13 inches. So since we're doing in terms of r, it's going to be C equals 2 pi r. And then we just plug in all the information we have. We have the 2, the pi, we just leave pi as pi, and then plug in the radius with 13. You multiply the 2 and the 13, you get 26. And then you just have your answer, 26 pi inches. You could leave it like that. Sometimes they may ask you to give an exact value. Then you just multiply pi with 26 and you get 81.7 inches. They're both the same, it's just one is left in pi, the other one is a value. All right, let's do the next one. Find C if D is equal to 6 millimeters. They give us the diameter. So we're not going to be able to use C equals 2 pi r. We will use C equals pi d. And then you just plug in your 6 for d, and then you get just 6 pi millimeters, or if they ask you for exact amount, it'll be 18.8 millimeters. All right, let's do the next one. They say that find d and r to the nearest hundredth if c is equal to 65.4 feet. They gave us a circumference. Now we need to find both d and r. So I'm going to find r first. So I'm going to do c equals 2 pi r. I'm going to plug in all the information I have. C is 6.5, and then we're looking for r. So in order to solve for r, I'm going to divide 2 pi on both sides. So that cancels that out. And then I'll have r equals, and I'm just going to divide 2 into 65.4. Oops. Change that. And that will give me 32.7 pi. But if I wanted to have like a value, an exact value for that one, then I would just multiply it by pi, and I would get 102.7. All right, so now they want us to find d. You could use the formula c equals pi d to find d, but you have r, and we know that r, the diameter, is equal to twice the radius. So then we're just going to do, I'm going to change that to another color, which I have the right one, yeah, red. So I'm going to do d equals 2r, and then that'll give me 2 times 102.7, and I'm going to multiply that, and that'll give me 205.4 for the diameter. I'll put that in feet. And the other one should be in feet also, since they gave us a label. So there you go. I found R and I found D. But again, you could find D by using, if you did the D first, then you would use C equals pi D, and then do half of D to find your R. Right. So let's go on to the next. Now we're going to do this example applying circumference. So everything we know about circumference. But there's a little more things that we need to apply to this problem that we learned in previous lessons ago. So let's start. So they say find the circumference of circle K, and there's a hint. What kind of special right triangle is in the diagram? So look at the triangle. It's a right triangle because it's a 90-degree marker. And when it comes to figuring out what kind of triangle, let's take a look at it. This triangle is made up of the hypotenuse, which they gave the label, the value of 3 square root of 2. And then we have K and another segment going to that point on the circle, and then K and another thing. So I'm going to just put letters on that so that way we can distinguish. So this is KA and this is KB. So we have KB and KA. What are they in the circle? They're radii. They're the radius. And what we know about radius in a circle, they're all the same length. So that means that KA and KB are going to be congruent. So whatever value you have for KA is going to be the same for KB. Now, because we know that, what type of triangle has two congruent sides? If you said isosceles, that is correct. So that means if the two sides are congruent, then the two base angles are congruent. So that means angle A and angle B are also congruent. So what special triangle that we learned that has the same base angle, same congruent sides, congruent base angles? That would be the 45, 45, 90. So the 45, 45, 90 has a ratio that's attached to it. I know some of you may have forgotten, but if you said x squared of 2, then you are right. So we have the 45, 45, and we have the x squared of 2 ratio. So remember when we did problems with that? So that way you'll be able to find the radius. So we're looking for x, which is the radius of that circle. So I labeled everything in that circle. And let me make this bigger so we can see it. So we have 90, got 45, 45, and we know that the ratio is x squared of 2. So x and x represent the legs of the triangle, so the radius, and then we have the hypotenuse, which is x squared of 2. Now, what was the next step? We need to solve for x. So since we have one side that has a value, which is 3 squared of 2, we're going to set that ratio equal to that value. So I set it equal, and then now I solve for x. I'm going to divide square root of 2 on both sides, and it's simple. I can cancel it on both sides because there's one on top, one on the bottom, and I'm left with 3. So x equals 3. So that means that radius is going to be 3. All right, so I'm not done yet because I still need to find the circumference of the circle. Because I have the radius, then I have to figure out which equation I'm going to choose. C equals pi d or C equals 2 pi r. I'm going to choose C equals 2 pi r since I have radius. I plug in all the information and then I solve. And I get 6 pi, or if they give an approximate value, 18.8. And that is the circumference of circle K. So again, stuff will be incorporated when it comes to dealing with circle. So it's just not plain circle, finding the circumference, finding the radius. That's too easy. We're going to put stuff that you already learned, like special triangles and all that fun stuff, and mix it in all together to find pieces within the circle. Right. So that we have reached the end. So just go and do a recap of what we learned today. We learned about circle, what a circle is and its parts. We know a circle is made of infinite numbers of points that are all equidistant from the center. It has a chord, which is a segment that touches the circle, 2 endpoints touches the circle, diameter that goes through the center of the circle, and a radius which is half the diameter and starts at the middle of the circle and goes to another point on the circle. We can identify a circle by calling it circle whatever letter, or with the symbol, with a circle with a dot that looks like an eyeball and its letter. We also learn about circumscribe and inscribe. Circumscribe is basically a circle that is drawn outside of of a shape, whatever shape it is, and inscribe is a shape that is drawn inside the circle. Or it could be another shape, but in this state, since we're talking about circle, it's drawn inside the circle. We also learned about the radius and diameter. Radius is half the diameter, and diameter is twice the radius. And we learned about the circumference of a circle. It's basically the distance around a circle. So basically, length. You have two formulas, c equals pi 2 pi r, or c equals pi d, depending on what they give you. If they give you radius, you use 2 pi r. If they give you the diameter, pi d. And the last thing we did was where we had to find the circumference, but with the missing pieces, whether there's a triangle or a radius or whatever it is, in order to use those pieces to find the circumference. All right, so if you have any questions about the intro to circles, email me and I'll help you out. But this concludes our lesson, and have a good day.